Welcome back to General Chemistry Mini Lecture Series, Lecture 21, Oxidation Numbers or Oxidation States. Oxidation numbers are imaginary charges assigned to each element in a reaction based on a set of rules. So oxidation numbers will allow us to determine the electron flow in a given chemical reaction. Although they look like the same, oxidation numbers are not ion charges. Ion charges are actually real and measurable charges, while oxidation numbers or oxidation states are just imaginary. So here are a set of rules for assigning oxidation numbers. First, free elements have an oxidation number of 0. Element potassium, oxidation number 0. Element chlorine, oxidation number 0. Monatomic ions have an oxidation number equal to their charges. Potassium positive 1, and then the oxidation number is positive 1. Chloride carries negative 1 charge. The oxidation number is negative 1. The sum of the oxidation numbers of all atoms in a neutral compound that has to be 0. Let's say for the oxidation number, the total oxidation number for potassium chloride, that should be 0. Positive 1 plus negative 1, that's 0. And the sum for oxidation number of all atoms in a polyatomic ion equals the charge on the ion. For example, sulfate, the overall charge is negative 2. Therefore, the overall oxidation numbers should be negative 2. So group 1A elements have oxidation number of positive 1, just like their ion charges. And group 2A elements, they have oxidation number of positive 2 in all their compounds, like calcium, positive 2. And then for those nonmetals, we will use the oxidation numbers shown in this table. Fluorine should be always negative 1. For hydrogen, except in metal hydrides, should be always positive 1. Oxygen, except in hydrogen peroxide, should be always negative 2. And group 7A, mostly negative 1. Group 6A can be negative 2. And group 5A can be negative 3. But those nonmetals may also carry oxidation numbers other than what stated in here. Now let's address oxidation and reduction. Oxidation occurs when an atom's oxidation number increases during a reaction. Reduction occurs when oxidation number decreases. When an atom loses electrons, oxidation occurs. Its oxidation number increases, it is oxidized, and it is a part of a reducing agent. When an atom gains electrons, reduction occurs. Its oxidation number decreases. It is reduced, and it is a part of oxidizing agent. If you recall the guidelines for oxidation numbers, what you just learned a while ago, for hydrogen, when it combines with nonmetals, it should be always positive 1. Since there are 4 hydrogen, so then the hydrogen part should have a positive 4. This overall is a molecule. There's no charge, all right? So therefore, the overall oxidation number should be 0. So we have positive 4, then carbon has to be negative 4. Negative 4 plus positive 4 equals 0. Oxygen, that's a molecular element. So the oxidation number should be 0. It's not combined with anything. Except in hydrogen peroxide. Oxide should always have an oxidation number of negative 2. Since there are 2 oxide here, therefore the total number of oxidation number for oxide should be negative 4. Because this is a molecule, the overall charge is 0. That means the overall oxidation number should be 0. So therefore, what plus negative 4 equals 0? Obviously, positive 4. So therefore, that should be positive 4 for carbon. So for hydrogen again, should be positive 1, and oxide, negative 2. The oxidation number for carbon in methane is negative 4. But after the reaction in CO2 is positive 4. You see, oxidation number increases. And then this reaction is called oxidation, or we call this half reaction is oxidation reaction. And then methane is oxidized. If a substance is oxidized, then it is the reducing agent. Let's look at oxygen. Before the reaction, oxidation number is 0. After the reaction, oxidation number negative 2. So therefore, oxidation number goes down, and this is a reduction. Oxygen is reduced. Then oxygen itself is the oxidizing agent. Oxygen oxidizes methane because methane is oxidized. Let's take a look at this example. For hydrogen, unless it combines with metal, always positive 1. And there are 2 hydrogen, so therefore sulfur should be negative 2 because the overall should be 0. Positive 2 plus negative 2 equals 0. In nitrate oxide, negative 2. There are 3 oxides that give us negative 6. Then what kind of oxidation number for nitrogen? The overall negative 1, obviously. Negative 6 plus 5 gives negative 1. Hydrogen, again, positive 1. Sulfur here is in the elemental state. If elemental state, oxidation number is 0. In nitrogen monoxide, oxide, negative 2. And then nitrogen has to be positive 2 because overall is 0. Here again for hydrogen positive 1, oxygen negative 2. If we look at sulfur right now, the sulfur from dihydrogen sulfide, the oxidation number for sulfur here is negative 2. And then after the reaction, sulfur becomes an element just by itself. So therefore that's 0. So we can see the oxidation number increases, then this half reaction is oxidation reaction. Then H2S is oxidized, and dihydrogen sulfide is the reducing agent. Now let's take a look at nitrogen. Nitrogen, the oxidation number is positive 5. After the reaction, nitrogen in nitrogen monoxide is positive 2. So positive 5 to positive 2, oxidation number decreases. That's reduction reaction. Therefore, nitrate is reduced, and nitrate is the oxidizing agent. Okay, now let's assign an oxidation number to each element in the following species. Copper, no charge, which means its in the elemental form, oxidation number should be 0. Copper 1, this is a monoatomic ion. The oxidation number equals charge. Positive 1, the charge is a positive 1, and then the oxidation number is also positive 1. This is another monoatomic ion. Again, oxidation number equals the charge. Charge is 2 plus, oxidation number plus 2. Okay, this overall molecule's oxidation number is 0. All right, but from what we learned previously, chlorine in this case should be -1, group 7A, -1. And there are 4 chlorine, that should be total of -4, and then that gives carbon positive 4. Positive 4 from carbon plus -4 from the 4 chlorine gives 0. Overall oxidation number for this compound is 0 because it's not an ion. Okay, and we know magnesium is group 2A, always positive 2. Then bromide, there are 2 bromides, that should be -1. Again, that's a group 7A, typically should be -1. This one is a polyatomic ion, and the overall charge is 2 minus. Therefore, the overall oxidation number should be -2. Oxide should be -2 from this table. Then, let's calculate the oxidation number for sulfur. Each oxide -2, and then we have 4 oxides, that's -8. -8 plus water number equals -2. The overall, obviously, 6. Here is end of lecture 21, question number 1. In ammonia, the oxidation state of each hydrogen is +1. What is the oxidation state of the nitrogen atom? Okay, the total oxidation number in ammonia should be 0. Another way to express that is the oxidation number for nitrogen plus the oxidation number for 3 hydrogen. That should equal 0. Okay. Then the oxidation number for nitrogen plus, we already know the hydrogen's oxidation number is +1. Then that should yield oxidation number for nitrogen. Basically, this is the X, or this is question mark, all right? So the oxidation number for nitrogen, or X, plus 3 equals 0. Then what should the X be, or what should the oxidation number for nitrogen be? That should be 0 minus 3. Move the 3 to the other side, and that's -3. So therefore, 4 should be the correct answer for this question. Those are the additional quiz questions. I will see you guys in lecture 22. Happy learning chemistry!